Welcome to the DIY Honda Garage channel. The DTC P145F pertains to a performance issue within the Evaporative Emission Control System, specifically related to the leak check module pressure sensor. This diagnostic trouble code indicates that the pressure within the system has not remained within specified limits for a certain duration, as monitored by the Powertrain Control Module, PCM. The PCM is the central computer that manages engine and emission systems in the Honda CR-V, and when it detects a discrepancy, it logs the DTC. Identifying and rectifying P145F is crucial for ensuring that harmful emissions are effectively managed. Ignoring such issues could lead to decreased fuel efficiency and potential environmental impact. This guide will outline the components involved, possible causes, and detailed troubleshooting steps necessary to address the P145F code, alongside other related DTCs. The Evaporative Emission Control System in the Honda CR-V includes a critical component known as the EVAP Leak Check Module, ELCM. This module is responsible for monitoring the pressure of the fuel vapor system to ensure that no leaks are present. The pressure sensor within the ELCM plays a vital role by measuring the vapor pressure in the system and relaying that information back to the PCM. Located near the fuel tank, the ELCM is integral to optimizing vehicle emissions and achieving compliance with environmental regulations. The PCM, which processes input from various sensors, is usually located in the engine compartment and is responsible for making adjustments based on the data it receives. When the pressure readings fall outside of predefined parameters, the PCM detects an irregularity and registers the DTC P145F, indicating a potential leak or malfunction within the system. There are several identified possible causes for DTC P145F. One common issue is blockage within the ELCM system, which may prevent proper venting and pressure measurements. This blockage can arise from debris or contamination in the system components, such as the drain tube or filters. Another significant contributor could be a faulty EVAP leak check module itself. This malfunction may manifest in inaccurate pressure readings that lead the PCM to log the error code. Additionally, wiring issues within the system can result in improper signals being sent to the PCM. Each of these potential causes needs to be investigated to determine the precise origin of the problem, as effective troubleshooting directly influences the success of repair efforts. The presence of DTC P145F can trigger several observable symptoms that require attention. One of the most noticeable indicators is the illumination of the check engine light on the dashboard, alerting the driver to an emissions-related issue. Drivers may also experience a noticeable reduction in fuel efficiency due to improper management of fuel vapors. Furthermore, the vehicle may display an emissions system warning, signaling that the emissions control measures are not operating as intended. If these symptoms are ignored, they can lead to increased emissions and potential complications with vehicle inspections. Recognizing these signs early can help address the underlying issues more effectively and maintain the vehicle's performance and environmental compliance. The first step in troubleshooting DTC P145F involves setting the vehicle to the on mode without starting the engine. This action allows the necessary electronic systems to power up and prepares the vehicle for diagnostics. Utilizing the Honda Diagnostic System, HDS, you will perform the EVAP Leak Check Module test to assess the function of the ELCM. This test will help determine if the module is working correctly or if it is causing issues with pressure readings. If the HDS indicates that the test result is not okay, this confirms that the fault has been duplicated, setting the stage for further diagnostic procedures. Understanding the outcomes from this step is essential. as it will guide the technician on the subsequent investigative actions to take. The next troubleshooting step involves a hands-on approach to inspect the ELCM system. Begin by disconnecting the drain tube from the EVAP leak check module. This step opens the system for further examination, allowing you to directly assess the functionality of the components involved. After disconnecting the drain tube, you'll connect a hose to it, followed by attaching a vacuum pump or gauge, rated from 0 to 30 inches of mercury. Applying pressure to the hose will enable you to evaluate the integrity of the system. If pressure is effectively applied and the readings yield expected results, this may indicate that the ELCM system is functioning correctly. However, any irregularities during this test require closer inspection of the module and its related components. Continuing with the hands-on troubleshooting, once the hose is connected to the drain tube and the vacuum pump is in place, you will apply pressure to the hose. This step is critical, as it helps to simulate the operational conditions of the EVAP system. Monitoring the pressure stability during this application will reveal whether the system can maintain appropriate pressure levels. It is crucial to understand the expected norm, which generally requires that pressure should not be held excessively. Any anomalies, such as unexpected pressure retention, could indicate problems with the ELCM or other components in the evaporative system. Thoroughly documenting your findings during this process assists in deciding the next steps toward diagnostic resolution. After applying pressure, you should check the rate of pressure change. This examination is crucial for determining if there are any leaks or inefficiencies within the system. If you observe that the pressure change is less than the specified value within the required time frame, it suggests a significant issue with the canister or the ELCM system. Conversely, if pressure levels return to expected ranges in a timely manner, the issue may lie with other components of the EVAP system, such as the leak check module itself. Identifying these nuances is essential in diagnosing the root problem accurately. Documenting the conditions under which you measured the pressure change will also be beneficial in guiding next steps in the repair process. Upon completing repairs related to the EVAP system, it is imperative to perform a final verification step to ensure that those repairs were successful. First, confirm that any DTCs stored in the PCM have been cleared following the repair work. It's best to utilize the HDS for this process to ensure accuracy. After clearing the codes, test drive the vehicle under various operating conditions to assess the reliability of the repair. Look for any reoccurrence of warning lights or performance issues during this drive. If the check engine light remains off and there are no symptoms present, it indicates that the repairs have been effective. This final verification step ensures that the repair process has fully resolved the underlying issues associated with the P145F DTC. Preventive maintenance plays a vital role in avoiding the recurrence of issues related to the DTC P145F and similar error codes. Regular system inspections should be scheduled to check for blockages, leaks, and overall system integrity. These inspections will help catch any potential problems early before they escalate into more serious issues. Additionally, scheduling regular replacements of filters within the EVAP system can prevent unnecessary strain on components, thereby extending their functionality. Maintaining clean filters ensures optimal airflow and pressure, crucial for the effective performance of the EVAP system. Taking the time to implement such preventive measures can significantly enhance the reliability and efficiency of the vehicle while ensuring compliance with emission standards. In conclusion, addressing DTC P145F effectively requires a comprehensive understanding of both the symptoms presented and the detailed troubleshooting steps outlined in this guide. Recognizing symptoms like the check engine light and reduced fuel efficiency prompts timely action, while following the structured troubleshooting approach ensures systematic identification of the fault. Each component's role and its interaction within the evaporative emission control system must be well understood to make informed decisions. After performing repairs, final verification remains critical to ensure reliability. Adopting preventive maintenance practices will further safeguard against the recurrence of the DTC, contributing to the long-term health and performance of the Honda CR-V. By adhering to these guides, technicians can facilitate efficient repairs while enhancing vehicle reliability. Please like and subscribe to the channel. See you next time.